Then the binary conversion.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Bhaskar.
Sir.
Yes. What exactly are the CIDR values we have for class A, class B, and class C?
Sir, for class A it is 255.
CIDR values.
Sorry, 8. Class A is 8. Class B is 16.
Slash 8. Slash 8.
Class A. Yes, sir. Class A.
It is slash 8.
Sorry, /8, and then class B is /16, and class C is /24.
Slash 24. Okay.
Yes, sir.
And this slash 8 simply means what?
Sir, it defines the number of network bits in the IP address.
Okay. Akash.
Yes, sir.
Tell me the subnet mask of /29.
Subnet mask of /29 is 255.255.248.
Anjali. Anjali. Akshay. Akshay.
Yes, sir. Yes, sir.
/13. Subnet mask is what? /13. Akshay.
Yes, sir. Hello.
/13. Subnet mask is what?
Yes, sir. 255. 255.248.0.0.
.0.0. Okay. Ganesh.
Yes, sir.
/22. How many ones are there?
How many?
How many ones? In binary, how many ones are there in /22?
I can't understand what is this.
Like the binary conversion, how many
Yes.
ones are there in /22? Yes, Ganesh.
Sir, I know subnet mask, but what
The
you are
binary
asking?
conversion is there, na?
Ah, yes, yes.
Yes. So how many ones are there in /22?
Sir, are you asking for network bits or host bits?
Yes. One means what? One mean what?
One means network host.
So how many ones are there in /22?
22, sir.
And how many host bits?
10, sir.
10 host bits are there. Any?
Yes, sir.
Yes. What is a subnet mask? What is subnet mask?
So it tells about two parts of how many is network part and how many is host part.
How many is network and how many is host? Okay. Why it is required in IP address?
To identify the host part and network part.
IP address without subnet mask is valid or invalid?
Yes.
It is valid.
What, sir?
IP address without subnet mask, is it valid?
Yes.
It's valid. Are you sure? An IP address without a subnet mask, is it a valid address?
No, sir.
No.
No.
Means is it mandatory to give a subnet mask?
Yes.
Okay.
Because through subnet mask only we can know that how many is network part and how many is host part in any IP address.
Okay. Kuldeep.
Yes, sir.
Powers of 2. The powers of 2. 2 raised to 0 to 2 raised to 16. Tell me the powers of 2.
Yes, sir. पता नहीं सर डिवाइडिंग कर पाया मैंने सर
Kuldeep.
हाँ सर हेलो
Yes, Kuldeep.
सर मैं रिवाइज नहीं कर पाया सर मैं थोड़ा बाहर था सर
अच्छा.
करूँगा सर मैं
Okay. Kashif is there.
Yes, sir.
Kashif. Yes. Powers of 2. From 2 raised to 0 to 2 raised to 16.
Sir. Sir, 2 raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. And 2 raised to 6 is 64. 2 raised to 7 is 128. 2 raised to 8 is 256. 2 raised to 9 is 512. And 2 raised to 10 is 1024. 2 raised to 11 is 2048. 2 raised to 12 is 4096. And 2 raised to 13 is 8192. And 2 raised to 14 is 16384. And 2 raised to 15 is 32768. And 2 raised to 16 is 65536.
Is 5536.
Yes, sir.
And 2 raised to 24 is what?
2 raised to 24 is 1677216.
1677216.
Yes, sir.
Okay. Okay, everyone. So here exactly we are discussing about subnetting. Okay, very important concept of your CCNA. This is the concept which is kind of mandatory for you to know as a network engineer to work in the company. Okay, and all these things what exactly we have discussed so far in the subnet masks idea. Okay, IP address, everything is coming over here in one place. The powers of 2, the binary conversion. Okay, definitive binary conversion. Okay, all these ones and zeros. This is the calculation what we are having over here. Okay. So first of all,
So your voice is not getting.
okay, who is having the issue? Mary. Mary, can you hear me properly?
But can you please speak loudly, Bita?
I'm speaking louder only. Okay, all of you, can you guys hear me properly?
Yes, sir.
I'm here.
Yes, sir.
Yes, sir.
Yes, sir.
Maybe, maybe this might be a network issue from your side. Okay.
No, sir. It's quite slower.
Yes, because others are hearing it properly. Okay, my network is good. Okay, might be like what from your side you are having the issue. Okay, simply just disconnect and connect back. Okay. Now, this is what exactly we have to know first. Okay, before we start the submitting process. Uh, in interviews, most of the time, this type of questions are being asked. Okay, that in a specific class network. Okay, how many IP address we can give to machines? Because we have for class B and class C. These three classes are there in public as well as private. Class D and E, that is reserved for multicast and experiment and research purposes. And we don't have class D and class E available in private. But these three classes, class A, B, and C, these three classes are basically available in both public as well as in private. So from that context, we have the subnet mask, class A, B, and C only. So since every single IP address it is containing a network and host part, that is the reason we are using the subnet mask. These questions are being asked in interviews that in a particular class network, whether it's a class A or class B or class C, how many number of IP address we can give to our host machines? Okay. If we speak about a certain class network, and how many hosts are possible, because a network is always made up of hosts. Network is always made up of machines, and these machines are called hosts. Okay, how many machines exactly we can give IP address in a certain class network? So very simple calculation you are having. Okay, always remember that in any LAN, in any local area network, we have this 4 addresses available. Okay, the first address is the network address, the second is the first valid host address, the third is the last valid host address, the fourth is the broadcast address. These 4 addresses are available for every single network. Okay, whenever you have a network, always these 4 addresses will be there. Now the network address and the broadcast address, always these addresses are basically reserved addresses. Okay, these are reserved. Why exactly it is reserved? Because the network address identifies all the devices network itself. For example, if we have a network over here, if we have a network, then within the network we have all the systems, all PCs are there within our network, all PCs. Okay, all these PCs, it belongs to the same network. This network itself is identified using this network address. Okay, so all these machines belongs to which network? Because we have lots of network. When we are talking about internet is made up of all these networks which are connected together. So when we have all these type of networks, okay, available in internet, every single network, it needs to be identified uniquely, and there is a reason we are having a network address. Okay, so this network address cannot be given to a single machine. For example, if I want to give a network address to this machine, it is in the system cannot take its identity as the network identity. Okay, a network address cannot be assigned to a particular machine because it is the identity of all machines. Okay, All these machines belongs to which network? This is what exactly the network address it identifies. That is why this address is reserved and it cannot be given to a particular machine. Okay. The broadcast address always is reserved as well, because whenever any machine wants to communicate to all machines within the network, this is when exactly broadcast address is used. That is what we are calling one-to-all communication. Any machine, if they want to communicate to all the machines in the network, this is when this address is used. It can be any machine, whether this PC, whether this PC, or whether this PC. If any of the systems wants to communicate to all the systems in this network, this is when exactly they can use this address, is the broadcast address. And this is what we okay. So this type of reserved addresses you cannot give to any laptop, to any desktop, to any servers, to any routers, to any of these network devices. Okay, because these are reserved addresses. The address what we can give to our machines, like our PCs, in a network, is this range of addresses. It is called valid host range, and it basically starts from first to last. Okay. The machine which you give your first IP address, first host IP address. This is what exactly we call first valid host. And the machine which is provided with the last valid host address, it is the last valid host addresses. Okay, the last IP address from this range, it is basically the last valid host address. For example, if we have two PCs over here, so let's say a range. Okay, a range like 192.168.1.1 to 192.168.1.254. This is what we call a range. A range from dot 1 to dot 254, we have 254 IP addresses. Total 254 IP addresses are there. So the machine whom I'm giving this IP address, this is the first valid host, and the machine, this is the last address, 1.254. This is the machine which is getting this IP. Okay, the first and last valid host address. In between these, whatever address is there, these are basically called valid host range addresses. Like .2, 1.2, 1.3, 1.40, 1.50, like that. Okay, from 1.1 to 1.54, whatever will like what IP addresses are there, those are basically called the valid host range addresses. So always your machine, they're getting their IP addresses from the valid host range addresses. Okay. For example, if it is your PC, if it is your laptop, okay, to whom or to which you are giving your IP address, always this address is coming from this valid host range. You cannot give a network address to your machine, you cannot give a broadcast address to your machine, because these are reserved. Always the range of address which is physically coming for your PCs, okay, this is always coming from the valid host range. Okay. Now we are going to find out all these addresses, okay, using the subnetting and all these calculations. But when you are getting this type of questions, that in class C network, how many IP address? How many IP address means what? How many valid host address we are talking about? Okay, is possible. The valid host range. Then there is a very simple calculation what you can do using the default subnet mask. Since we know that it's a class C network, and class C network subnet mask says that we have 24 bits, we have network bits, and we have 8 number of bits, is a host bits. We're simply just calculating the host part. So we are using the powers of 2. We have 8 host bits. So 2 raised to 8 is 256. These are the total number of IP addresses. Total, including the reserved addresses as well. Okay, means the network address and the broadcast address. We are calculating every single address. Okay, in this particular calculation over here, the network and broadcast is also included in this 256 number of addresses. So since we are talking about how many IP addresses we can give to machines, machines means this is our host. We're specifically talking about this range. That is your first valid and last valid. So always, whenever you need to find out the valid host range addresses, always you have to subtract 2. Now this 2 is coming from this network address and the broadcast address. Okay, we are subtracting this 2 from 256 and we are getting the total valid host addresses. Okay. So total valid host address, if you want to find out, always you have to subtract -2, okay, from the total number of IP addresses you are getting in a particular class network. Always, this is the formula. Okay. So this is what you are getting. Your answer is 254 number of valid hosts in a class C network. Similarly, if we are talking about class B, the same calculation applies over here as well. In class B, we are having 16 number of network bits and 16 number of host bits. So 16 number of host bits means what? 2 raised to 16 is 65536 minus 2. That is your network and broadcast is getting subtracted, and you are getting 65534 valid host IP addresses. So total, how many number of machines you can give IP address in a class B? 6, 5, 5, 3, 4 machines. You can give IP address. Okay. All this number of machines, they will belong to the same network, same class B network. Same class B network. Okay. Similarly, the next class network, we are having class A. And the class A network, we are having 8 number of network bits and we have 24 number of host bits. Okay, these are host bits. So 2 raised to 24 is 160,77216 minus 2 is 160,77214. This one number of machines we can give IP address. Okay, means in a class A network, okay, in a class A network, you are getting 1677721 214 machines. You can give IP address. Okay. Now clearly you can see the class A. In class A, we are getting this many number of IP address, means we can give this many number of machines IP addresses. In class B, you can see we are getting this many number of machines IP addresses. And in class C, we are getting this many number of IP addresses. So that is the reason in class A always is used for big size network. Okay, when you have very like a huge number of machines, okay, like 1 lakh, 2 lakhs, okay, you are having this many number of machines are available. This is one exactly you can use class A network. Okay. When we have machines within this range 65534, this is when we are using class B. So this one supports medium size network. And when we have less than 254 number of systems, this is when we are using it in small size network. Okay. So that is why exactly the classification is available everyone. The big size network, medium size network, and small size network. Always we are having these 3 classes. Okay. When the number of machines is exceeding 254, this is when we are using class B. When the number of machine is exceeding this number, this is when we are using class A. So very big organization like Google, okay, Cisco, Microsoft, okay, these are very big enterprise level organizations. This is one exactly you will be seeing that they're using class A or class B network. But most of the time you will see that the companies are using class C or maximum to maximum class B network. Class A network is very huge size companies. Okay. While we have lots of machines, like lakhs of machines are there. This is one exactly you would see class A network is getting used. Okay, everyone, now this part understood, right?
Sir, can you repeat the network of this part, sir?
Which one?
Network at this part. What does it do exactly?
The network address is nothing, but it is the identifier of your machine's network itself. For example, if we are talking about a network like this, okay, this is a network, right? This is your local LAN. If this is your local LAN, then all these machines, okay, like your PCs, your laptops, okay, all these machines they belong to the network, right? All these machines are part of this network, right?
Yes, sir.
Yes, sir.
Yes, sir.
So this network address is the identity of every single of these machines, right?
Yes, sir.
All these machines belongs to this network. So you cannot give any particular machine the network address. This network address you cannot give because it is the identity of every single machines of your network itself. Okay. So this network address you cannot give to any single machine. Always you can give IP address from which range? Valid host range.
And sir, what about broadcast address?
Broadcast address is whenever you are communicating, for example, if this is your network and you are having all the systems available within network. So at any given point of time, if this machine wants to communicate to this machine over here, as well as this machine, means all the machines. This is when they're using which address? Broadcast address. Because broadcast address is what? One to all. This is one, right? And this is your all, right? Yes or no? This is all the machines.
Sir, too much noise is coming from someone's side.
Okay. Okay, so anyways, this is one-to-all communication, okay? And this address, anyone can use it. Like if this machine wants to use it, then he can also use it. If this machine wants to use it, at the time also it is getting used. So it is like every single machine can use these addresses. That is why it cannot be any one machine's unique identity. Okay, when we talk about IP address, it should be a unique address, okay, which is given to machine. But since these addresses are basically used by everyone, broadcast address is used by everyone, network address is used by everyone, this cannot establish the unique identity of a particular machine. That is why we don't use it. Okay, always we are using the IP address for our machines from the valid host range, because that is the range which is uniquely identifying every single devices within a certain network. Understood? All of you got it right?
Yes, sir.
Yes, sir.
Okay. Now, in the organization, it is not like this, everyone. Okay. In the organization, always we are having this type of departments. Okay, this is the structure of the company. We're talking about HP organization over here. This is what exactly you are having the departments. Okay, in every single company, they are having departments. And in these departments, they are having the machines. Okay. And we have employees, okay, who are working in these departments. Employees are working in these departments with these machines. Okay. So department wise, always you are having like 100 machines in one department, 50 machines in another department, 10 machines in one department, 4 machines in another department. These are basically the number of requirement but we are having in each and every single departments. Okay. So in the organization, always you have machines available under certain departments, okay, in departments. So all these machines, okay, what exactly we're seeing over here is one. For 100 machines, how many IPs we need? Actually, 100 IPs, right? 100 valid host IPs, correct? Yes
Yes,
or
sir.
no?
Yes.
100 valid host IP address. Similarly, in marketing department for 50 systems, how many is required? 50,
50.
50.
right? 50 valid host. Similarly, for 10 number of machines, how many addresses required?
10 valid host.
And for finance department,
4 valid valid.
only. Remember, we are talking about valid host IPs, means this range, first valid host to last valid host. Okay. So for this much amount of addresses, if we are going for class A network or class A subnet mask like this, if I give this entire subnet mask to this department, what will happen? So many IP addresses will be wasted. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Because we are
Sir.
getting what? 254 and we need what, 100? So 254 minus 100. That is your, how many IP addresses are getting wasted?
154.
154.
154 IPs are getting wasted, right? Okay. Now you can see that the waste is minimum over here, right? 154. If I talk about a class B, if I give this subnet mask to 100 machines, then how many IP addresses are getting wasted? This is your 65534, right?
655
Minus 100. How many?
6,436.
65434, right?
36.
65434, not 36. 36 is including
Yes, sir.
the
4.
network and broadcast
And
address, right? So
Yes,
when you
sir.
are calculating the valid host address, always subtract the network and broadcast. So you can see the address is getting wasted a little bit more over here, right? Because earlier in class C, we are wasting only 154 IP address. Right now the wastage is more. Similarly, if I talk about a class C network, then class C network, how many IP addresses will be wasted? 16,777,214, right?
Yes, sir.
Sir.
Minus 100.
677
Minus
down
100
14.
will be 16,777,114,
1-4.
right?
14.
So you can see the address wastage is getting bigger, right?
More.
When we are moving to class B or class A, always.
Yes.
Okay. So in which subnet mask we are getting the lowest wastage address? In which subnet
Class C.
mask?
Class C.
Class C.
C.
That is why class C is very popular. Okay. Everywhere you will see class C subnet mask. Okay. Because class C basically gives you less number of wastage of IP addresses. Okay. But still we are wasting IPs. Even in class C also we are wasting IPs. 154 IP addresses are given, okay, are wasted. So what exactly we are doing is we are dividing the class C subnet mask as per the requirement, so that we can reduce the wastage of this IP address, okay, over here. For example, for 100 machines, what exactly is the accurate number of, like, what subnet mask, what we can give over here? We are dividing this particular subnet mask. This is the main idea. Okay. In subnetting, what we are doing is we are dividing one big network. Okay. Like, let's say that this is /24, right? This is /24. This is your class C, right?
Yes, sir.
Yes, sir.
Plus,
Yes, sir.
we are dividing this /24 as per the requirement. Okay, like this. we're dividing it like this. So in some places we are giving slash 25. In some places we are giving slash 26. In some places we are giving slash 27. In some places we are giving slash 28. All these things we are doing it as part of the requirement. Okay. This is when your slash 24 is getting divided and we are creating all these subnet masks as part of the requirement. This is what you are doing actually. Okay. Because if you don't divide this slash 24, you are wasting your IP address so much. But when you are dividing it, then you are reducing the wastage of IP addresses. But I'm not saying that 100 machines you will be only dividing IP address as part like what 100 systems only. Like 100 machines, 100 IP only you can get. Okay, by doing subnetting. I'm not saying that. I'm saying that you will be reducing. Earlier you were wasting 154 IP addresses. Right now the wastage will be less when you do subnetting. When you were using slash 25 or slash 26, the wastage will be less. Okay. The main idea of doing subnetting is to reduce the wastage of IP addresses. Okay. So this is what exactly is the definition of subnetting upfront. It is the process of dividing one big network, like one class C, class B, class A network. And we are basically coming up with our subnet masks. Okay, smaller subnets are created. This is your big network. Okay, so this, let's say that this is your slash 24. When you divide it, this is when you create subnet. Okay, this is your subnet. This is one of the subnet. Okay, all these are subnetworks. Okay, all these are subnetworks you are creating. Okay, and this is the process. Okay, the process is called subnetting. The way to divide this class C, class B, or class A subnet masks to create like what small subnets. Okay, these are basically called as, the process is called as subnetting. Okay, so to do subnetting, we are having two methods. Okay. The first method is VLSM. The second method is FLSM. Okay, VLSM stands for variable length subnet mask, and FLSM stands for fixed length subnet mask. Okay, so what exactly the method we are using today is this. This method is used, okay, in today's network. We are always using VLSM. Why we are using VLSM and not using FLSM? Because in this method, you must have the same type of requirement. It means if you have a requirement of sales department, 100 systems, means your marketing department also must have 100 systems, which is not true, okay, which is not logical or reasonable. Because in a company, every single department having the same number of systems, the same number of systems in every single department, it is not possible. Okay, it doesn't sound reasonable. That is why exactly we don't use this fixed length subnet mask, because if we are using slash 25, let's say that this in this department we are using slash 25. It means for this department also we have to use slash 25. This department also we have to use slash 25. Okay, all these departments we have to use slash 25, which is fixed. The subnet mask is always fixed. Okay, it is not changing. The requirement is also fixed, it is not changing. Okay, everywhere you are having 100 systems, over here also 100 systems. Okay, this doesn't sound reasonable. Okay, and that is the reason we don't use this FLSM method these days, because in the company always we get variable number of requirements. Okay, variable number of machines. Like some department having 100 machines, some department having 50, some department having 10, some department. This type of requirement sounds reasonable. But in a company where every single departments you are having the same exact number of systems, this doesn't sound reasonable these days. Okay. That is why we don't use FLSM so much the way we are using VLSM. Okay, so the method, what exactly I'm going to show you, that is the VLSM method. how to perform this VLSM. But all of you simply just take the screenshot of this first. Take the screenshot, Sakuma.
Done, sir. Wait, sir. Wait. Done, sir.
Take them.
Yes, sir.
Okay. So now we are having this. This is your requirement. As you can see, we have our sales department, our finance, our technical department, and our marketing department. These are all the requirements. Okay, every single companies, they have requirements of systems in a certain department, and subletting is not possible if you don't have any requirement. Subletting is totally based on a requirement only. When you have number of systems, this is one exactly you can perform subletting. Okay, so all these requirements you are seeing over here, it is variable, it is changing per department. Okay, now in every single company there is a rule, everyone, there is a policy that sales department machines cannot communicate to finance department. Finance department machines should not be communicating to technical department. Every single department is separate. Every single department is isolated, okay, from each other. So all sales department machines, they can communicate with each other, okay, but they should not be communicating to finance department. That is why exactly we are doing subnetting, because by doing subnetting, we are creating subnets, which is totally separate from one another. Okay, so this subnet is totally separate from this subnet. This subnet is totally separate from this subnet. Okay, so any machine which basically belongs to a particular subnet, they can communicate within that subnet, but they cannot communicate between subnets by default. Okay, so to do subnetting, always you have to remember the default subnet masks. Okay, your company will be giving you the IP address and the subnet mask which you have to use to do subnetting. Okay, always the company provides you that. They will tell you that, okay, you are having this type of requirement, sales, finance, technical, marketing, and this is the network what you are going to use to perform subnetting. You have to give IP address to all these machines, but make sure that these machines from these departments, they are not communicating with each other. Because in a network, when machines belong, okay, always they will be communicating. Okay, because that is the main purpose of setting up a network, to make communication. We want to divide this communication. Okay, sales department should not be communicating with finance department machines. So always this network address and the subnet mask, always they will provide you. Okay, now as you can see that we are doing class C subnetting over here. This is your class C network address and subnet mask. These informations will be provided to you by the company. Okay, so don't worry about this. They will tell you that what network address you have to use to perform subnetting, what exactly is the requirement you are having. Okay, after taking all these informations, then you begin the process of doing subnetting using VLSM. Okay, so here exactly you are having this default subnet mask, everyone, because we're calculating all the subnetting, okay, related informations based on the subnet mask over here and the network address. So always when you get the requirement, okay, when you are getting the requirement from the company, always you arrange it from highest. Okay, the requirement should be arranged properly, highest to lowest. Okay, always highest to lowest. This requirement should be arranged in this order. As you can see, I have arranged it in this order. First of all, 100, then 50, then 10, then 2. Okay, always you do that. You don't start from marketing department and you don't go all the way up over here, because this way you cannot perform subnetting. Okay. Always to perform subnetting, you have to start from highest and you have to go to the lowest. Always the requirement is like this. You have to sort it out in the proper order. Now, the first subnet, what exactly we're going to be creating, that is our sales department. Okay, for our sales department, the first subnet always is called subnet 0, because in networking everything starts from 0 only. Okay, subnet 0. Okay, we calculate everything from 0. Our octet also starts from 0 and it goes all the way up to 255. So this is what exactly is the calculation, what you were going to do. Okay, our main objective is to find out these addresses. In every single subnet, we are going to find out our network addresses. Okay, in this subnet, okay, all these on all these subnets, we're going to be finding out these 4 addresses. Okay, so how do you do this calculation? Over here, you are having the explanation, everyone. First of all, this is our subnet. You can see subnet number 0. We are doing subnetting for our sales department. 100 systems. Okay, so we have to find out the power of 2. Okay, the requirement is 100. Means 100 valid host IPs. You need 100 valid host IPs. 100 valid host IPs are required. So in this particular case, which particular power of 2 is giving you a value which is more than 100? Which value is bigger than 100? You have to find it. So 2 raised to 6, 2 raised to 6, if we are taking, then we are getting what? 64, right? Yes, 2 raised to 6 is 64. So 64 is lower than the requirement, right? This is the current requirement, 100. So which power we are taking? 2 raised to 7. So that is your 128, correct?
128.
So we are taking 128. So 128 means what? 128 means total IP address, right? Remember? The total IP address, including the network and broadcast, right? Yes or no?
Yes, sir.
Including network and broadcast, because always network and broadcast is there. This is the reserved addresses. So we have to subtract 2, right? So this network and broadcast address is getting subtracted, and we are getting how many valid host addresses? 120.
126.
So always compare this value, what you were seeing over here, this value with this requirement. Comparing this value, what exactly you are seeing? This value is bigger than 100, right? Yes or no?
Yes.
It should be equal. Remember, this value over here, it should be equal to or greater than. Okay, always it should be equal to or greater than the requirement. Okay, the requirement is how many? 100, right?
100.
So whatever value you are getting by subtracting 2 from the total number of IP addresses, always make sure that this value is equal to 100 or greater than 100. But it should not be less than 100. Getting my point? So this is what exactly we're doing, the calculation. Okay. Now why we are doing this calculation? It is basically to find out our subnet mask. Okay. Since we know that we are having a class C subnet mask /24. This /24 we are having 8 host bits, right? Always you do subnetting on network part or host part. Subnetting always you do on the host part. Remember, you don't touch these bits. These bits are reserved for network. We don't do subnetting in the network bits. Always we do subnetting in which particular portion?
Most part.
Host portion. Always. Okay. So how many host bits we are having in class C? Default? 8. Out of 8 host bits, how many bits we need for our 100 systems?
24.
7, right? Yes or no? We have already got it, right? This is the 7. So this is your 7 host bits, huh? 1, 2, 3, 4, 5, 6, and 7, right?
Yes, sir.
These are your 7 host bits. So what about this bit? This one? This bit cannot be 0, right? Because as per our calculation, we need only 7 host bits. So if we talk about bit, a bit is either what? 0 or 1, right?
1.
Either 0, it cannot be
More than
a 0, this bit cannot be 0, it must be 1, right? Yes or no?
yes, sir.
Yes.
Because we are having only two values, two possible values. If a bit cannot be 0, then it needs to be converted to 1. So right now we are having total how many host network bits we are having already? 24, right? And 24 plus 1 is how much?
25.
So can you see this 25 is coming everywhere?
Yes, sir.
Right. So slash 25. Now see, this is your subnet mask you are finding out. Okay. So what exactly is the value of this bit? What is the value of this bit? It's 128, right?
128.
Yes, sir.
Remember the values of an octet, right? This value is octet, this value 1, right? Then
Yes.
this value is
2,
2. Then this
4.
value is
4.
1 to 4, right? 1 to 4, 8, 16, 32,
10,
64,
13.
125. This is how you are having. So can you see the subnet mask over here?
Yes, sir.
255, 255, 255,
128.
and this is the 128.
28.
And this is your CIDR, right?
Sir.
This is the CIDR. Okay. So the network address exactly is coming over here on 92.168.1.0. You can see it, the same address, because this is our first address. Okay. An octet always starts with 0. That is your network address right now. So first value host address, always you have to increment this value, the last octet, by 1. Always. Okay. To find the first value host address, always you have to increment the network address last octet by 1. So last octet by 1 means what? You are getting what value? 1. Can you see the same thing over here? It is 128, right? 120 plus 1 is how much?
159.
129.
It is a formula. Okay. It is a formula that on the network address, okay, NAT address, last octet, okay, always you have to give 1 plus 1, okay, this is a formula, and you will be getting the first value post address. Now we need to find these two addresses, okay, but to find these two addresses we have to calculate something called a block size. Okay. So block size always is calculated using this formula. Okay, what exactly we need to do is we need to subtract the value of this bit. Right now we are having only one
28.
network bit, right? So the value of this bit is what? 128. So this 128 is getting subtracted from 256. Now why this 256? Because we are talking about an octet, right?
Octet.
These are 8 bits, correct? Yes or no?
Yes, sir.
So if we use 2 raised to 8, then how much we are getting? 256, right? 2 raised to 8 is how much? 256.
Yes.
And 0 to 255 is how much? Total?
256.
256.
So this is a constant value. This value is fixed. This is a formula. Okay, it's a fixed value. It's a fixed value. So what exactly you need to do in order to find the block size is you have to calculate the number of network bits what you have taken from host to network side. Okay, this is the network portion and this is the host portion. So how many number of network bits you have taken? Sorry, how many number of host bits you have taken to the network side? Only one, right?
Yes.
That one network bit value is 128. You have to subtract from 256 and you are getting the block size.
Yes.
Are you getting
Yes,
this?
sir. Yes.
For example, if I am having two network values,
Yes.
network, then it will be what? 128
192.
Minus
plus
192.
64. So it will be 192.
192.
So at the time over here it will be what? 192,
92.
right? And it will be
Yes.
64.
64.
Right. This is what you are having. Okay, the block size. Now, why we are using this block size over here? That is basically to find this address. Next subnet. Okay. The next subnet address always you can calculate using the block size. What exactly you need to do? Since we are doing class C subnetting, everyone, and in class C subnetting, we are having this much part we have network, right?
Yes.
And this much part we are having the host.
Yes.
So that is a fourth octet, right?
Yes, sir.
Yes.
Yes, sir.
Our host part starts at the fourth octet in class C.
Yes, sir.
So what we need to do? We need to add this block size where? Into the fourth octet.
Fourth octet.
Okay. Because in our subnet mask, our host part starts in the fourth octet. This is when the block size you have to add it in the fourth octet. And it becomes what?
192. 128.
1.128, right? So 128 plus 0 is what? 128.
128.
You are getting. Okay. Now, once you have got the next subnet address, finding this address is very easy, everyone. All you have to do, this is a formula, remember. All you have to do is subtract 1 from the fourth octet of next subnet address. And you are getting what? 127.
Broadcast.
That is your broadcast address. And subtracting 1 from this broadcast address, you are getting what?
Last valid.
The last valid host address. Okay, this is subtracting, you were doing. Okay, because class A, no, sorry, in class C, you are having up to this, you are having the network, right? Can you see that address remains same everywhere? Yes or no? This 192.168.1, it's not changing, right? It
Yes,
is
sir.
same.
Yes, sir.
In this, it is changing. Which octet is changing? The fourth octet, right?
Fourth octet.
Why the fourth octet is changing? Because in class C, host belongs to which port? The host bits fourth octet, right?
Yes, sir.
And we are doing subnetting on which octet? On the
Fourth
fourth octet. This is the calculation what we are having. To get the broadcast address, all you have to do is subtract 1 from your next subnet address, you get your broadcast address, and subtracting 1 from broadcast address, you get your last valid host. Okay, so let's take another example over here. There is your finance department. There is your subnet number 0, subnet number 1. So for finance department, we have to find the subnet mask over here. So to find the subnet mask, always we are using the default mask over here. So how many host bits we have? 8, right?
Yes.
So which power we are taking? Which power is bigger than 50?
2 to power
6, right?
Yes.
So you are getting 64 minus 2, you are getting 62.
You do.
So how many IP addresses are getting wasted? The wasted IP address will be
12.
12, right? 12. So Out of 8 host bits, how many we need?
4.
6. You need
Oh,
6, right?
Yes, sir.
You are having 8 host bits. Out of 8 host bits, you need how many?
6.
6.
6. So if you take 6 host bits, then we are getting 2 network bits, right, over here. Yes or no?
Yes.
These are your 6 host bits, and these 2 bits are going to the network. So already we are having 24, right? Slash 24 plus 2 is what?
26.
Slash 26. So 26 is what? Number of network bits, right?
Yes, sir.
Yes.
So our network address is coming. Can you see the same address is coming over here?
Yes, sir.
It is the same address, right?
Yes,
Over
sir.
here. Yes,
Yes, sir.
because we cannot use this network. This network address is already used over here. We already used it in subnet 0. So we cannot use the same network address for finance department. The next subnet address, why we are finding out? Because we have to give it into subnet 1. If this is your subnet 0 network address, then the next subnet address is subnet 1 address, right?
Yes, sir.
Yes, sir.
So the first valid host address will be what? 128 plus 1, right?
That's one.
So it becomes what?
120.
120. Then we have to find the block size. So to find the block size, what we are doing? We are simply
Total number of objects
subtracting
minus
the total number of network bits value. So that is your 128
minus 190.
plus 64, right?
Yes, sir.
So 120 plus 64 becomes what? 192. You subtract it from 256 and you are getting what?
54.
And this value we are adding it to which object? 120.
Network
And it
address.
becomes what?
128.
192.
92.
That becomes our next subnet address.
Yes.
So 192 minus 1 is becomes what? The broadcast address.
Minus.
Minus 1 is the broadcast address. And similarly, 191 minus 1 is what?
Last file is
Last
4.
valid host address.
The last valid host address. That's it. This is how you are going to find out. Okay. This is what we are doing subnetting. This is a VLSM. You can see that for 100 systems, we are having one subnet mask. For 50 systems, we are having a different subnet mask. It is variable. It is changing. Okay, always in VLSM, we are basically doing this change per requirement. Now, all of you have understood these two requirements.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So if you have understood these two requirements, can you tell me this remaining two requirements? Can you explain this? This is what exactly I have done. Can anyone explain this to me? Yes, who will explain this? Bhaskar,
Yes, sir.
this one, subnet number 2, you tell me what exactly is going on.
Okay. Okay, sir. So like in subnet 2, we are having 10 system. So we have to find out the value which is bigger than the 10. So as we know that 2 to the power 4 is 16. So it meets our requirement. So to find out the valid host address, we will subtract it with the 2. So total valid address will be 14. So as we can see, we have taken the 4 bits from here. So now our total network bits will be 28. That is the default 24 of class C and plus these 4, and remaining 4 will be our host bit. So Now, as we know that from the subnet 1, we get our next subnet address is 192.168.1.192. But now our CIDR notation value will be 28. And to find out the next block size, that will be our next that will be our next subnet address. So what we will do, we will sum all the value of the network bit which we have taken from the fourth octet. So the total value of that will be 240. So to find out the block size, as we know that the total octet value is 256. So we will subtract it with the subtract the 240 with the 256. So we will get the 16. And then when we add this 16 to our network address of this subnet, so we will get the next subnet address, that will be our 208. And from this now to find out the broadcast address of subnet 2, what we will do, we will subtract the 1 from our fourth octet value, that is 208. So we will get our broadcast address, that will be our 207. And to get and to find out the last valid host address, we will again subtract 1 from this broadcast address, so we will get 206. And if we want to find out the first valid host address, then we have to add the 1 on to the fourth octet value of the network address, so we will get the 193.
Okay, so like what, everyone got it, right?
Yes, sir.
The subnet number 2. Okay, now Annie, you go for this fourth one. Annie is there? Annie? Okay, Gaurav is there? Gaurav? Mukul,
Yes, sir.
you go on for this.
For subnet 3 marketing department, there are 2 systems. So we need more than 2 systems to have a valid host address. For that, we are going for 2 raised to power 2, which for that is answer 4. So, and my separating 2 for a network address and broadcast address, we get the 2 valid host address. For that, last bits will 26 will be the ones, and last 2s will be the zeros, and get for that CIDR will be 30, and then our next network address will be the next subnet address 192.168.1.208/30, and after that block size will be for us is 256, the whole address minus the ones and that we are added, that will be 252. The answer will be 4, which we'll add it in the network address, and that will be 208 plus 4. So the next subnet address will be 192.168.1.212, and after that we'll subtract it, the minus 1 from 212, we'll get the next broadcast address, that will be 0.211. Then after that we'll subtract minus 1 to get the last valid host address.
All of you got this requirement?
Yes, sir.
Yes, sir.
Okay. So everyone has got this particular subnetting, right? Class C subnetting clear?
Yes, sir.
Yes, sir.
Understood, right?
Sir,
Hmm.
sir, explain please one time. First valid address, where comes from 193?
It is nothing
Add
but
one.
simply you have to add the plus 1 into the
Okay.
network address last of it, always. You can see 208 plus 1 is what? 209, right?
Yeah.
192 plus 1 is what? 193. Like that. This is the
Sir,
formula.
can you explain block size again?
Block size, you can see how many bits you have taken, network bits. 4,
Four.
right? So 4 network bits means what? 128, 64,
64,
then
32,
32, and 16, right? Add them together. How much you are getting?
240.
240, right? You are getting
Yes,
4
sir.
ones, right? 4
Yes.
ones and 4 zeros. So when you calculate this 4 ones value, this one value is what? 128, right? Then this one value is what? 64.
54.
And this one value will be 32. This one will be 16. You calculate all this, you are getting what?
Yeah, okay.
So this is the 240. So total 16 you are getting, and 16 you have to add with 192, right? So just add them. How much you are getting? 208.
Yes.
Understood. Okay, so
Yes, sir.
if all of you are compatible with submitting, then I will give you some questions. You will have to do the calculations and you will have to tell me. Understood?
Yes, sir.
If you are comfortable. If you are not comfortable, tell me right now. If you are having any doubts on something, you can tell me. Yes, all of you. Ronit is
Sir,
there. Tell me,
hello.
tell me, Ron.
Sir, can you explain that the valid host address and subnet mask? As per my knowledge, means as I understand that the 2 raised to power 4 will be the last. We need to leave the last 4 octets from the last part as 0. Then we can just calculate the 4 ones, and that will be the address of 192. Is that correct?
That is correct.
Okay, sir. Okay.
This is about your finding the subnet mask. Always we need to find the
Yes, sir.
subnet mask for which we are doing this calculation.
Yeah.
Okay.
So yeah, so we need to leave the as if we take the 2 raised to power 4 or 2 raised to power 2, so the 2 will be leave from that last octet, like
This
in
two,
the
this two,
4.
okay, whatever power you are taking, right? These are basically ultimately we are using as host bits, age bits.
Okay.
These are basically zeros. If you are taking 4, it means what? 4 zeros.
4 zeros.
If you are taking 2, it means what? 2 zeros.
2 zeros.
Like that. Okay. Because always we have a default subnet mask. Our default
Yes,
subnet
sir.
mask of class C says we have 8 bits host.
Yes, sir.
But we cannot take 8 bits host for only 10 systems, right? Lots of IP
Yes,
addresses
sir.
will be wastage.
Yes,
Yes or
sir.
no?
Yes,
This is
correct.
one example we are using this formula over here. We are calculating that which particular value is like what? Equal to or bigger than 10 system.
More than.
Whatever power you are taking, it means that one number of host bits you need.
Okay, sir. Understand.
Okay.
Sir, I have one question, sir.
Tell me.
Sir, suppose we are having two networks, network A and B, okay, and both are using the class C address, and in both the networks, suppose we are having 254 machines, correct?
Yes.
And so in that case, we can directly assign the values to those machines from 1 to 254, correct?
That is correct.
So, sir, in that case, in both the network, IP address will be same.
No. This is
In
your
that
LAN
case, how we
1.
will differentiate?
This is your LAN 1, let's say. This is your
Yes,
LAN
sir.
2. This is your LAN 2.
Yes, sir.
All systems you have in LAN 1, they will be having their IP address from this network 192.168.1.0/24. This is one
Yes, sir.
network where you
Yes,
are
sir.
getting the 1.2, 1.1 to 1.254. You have the range, valid host range address.
Yes, sir.
Like 192.168, 1.1 to 192.168, 1.254. This is a short way. Okay.
Yes, sir. Sir.
You can give total 254 systems IPs, right?
Yes, sir.
Total 254 IPs. Similarly, your LAN number 2 will be different, right? It will be 192.168.2.0
Okay.
because 1 is already used, right, over here.
Okay.
So it will become what? Your network ID will be changed, right?
Okay.
It becomes 2. And all systems in this your network will be getting their IP address from which address?
2.1.
2 dot.
Okay.
So this will be 2.1 to 2.254.
254.
That is your total 254 systems.
Okay.
Getting
So,
your point?
yes, sir, I got it. So it means that if both these LAN IP service provider are different, still they will be aware of this thing, correct? If both these LAN IP service providers are different,
if both the LANs IPs are different, means there
IP
still will
service
be
provider, IP
okay.
service
Okay,
provider.
service provider is different.
Yeah.
Then
So in that case, they will be aware of that .1 means
yes,
this
if we
net.
are talking about public IPs always it is like what it is chargeable, right? And it's a unique address. These are private addresses, right? We are using 192.168. Okay, in the companies, when you are setting up a network, then you as a network administrator, either you are giving the IP address, or you are selecting that which public or private type of address you want to give to your machine, or your senior engineer will be giving you the instruction that this is the address what you have to give to this LAN, this is the network address. Your senior engineer will give you that information.
Okay, sir. Okay. Thank you, sir.
So one more doubt.
Tell me.
Yeah. How in the tech 10 systems, how we get the 192, sir, in network address?
How we are getting the 192? It is coming from the
Yes,
next
sir.
subnet address from here.
Okay.
This is the same address which is coming over here. Right?
Okay, so it will be carried forwarded to next. Okay, sir. Okay, sir. Okay. Thank you.
Okay. Anyone else?
Sir, how /28 came?
How /28 came? How many systems you need IP address?
10 systems.
Which power is bigger than 10?
2^4.
So how many host bits you have in class C?
4.
How many host bits in class C? How many host bits are there? Total?
8.
8 host bits, na? 24 bits are network and 8 bits are host. Yes or no?
Yes.
Yes. So out of 8 host bits, how many host bits you need? 4, right?
4.
Yes or no?
Yes.
4 host bits. So if you take 4 host bits, means this, and this, and this. It means what? All other bits are going, it is converted to ones, right? Yes or no?
Yes.
These are getting converted into ones. So what exactly are the value? This is 128, right? This is 64. This is 32. This is 16. Yes or no?
Yeah. Yes.
So already 24 is there. 24 number of network bits you are already having, right? /24 in class C. Plus 4 bits. So 24 plus 4 is how much? 28, right? Yes or no?
Yeah. Yeah.
Like, are you getting it? See the subnet mask over here. In class C, how many bits are network bits? How many bits are network bits?
24.
24.
24. And how many host
24.
bits?
8.
This is your network and this is your host.
8.
Always you calculate the default subnet mask. Okay, every single subnet mask what you are calculating for a subnet, always you use the default subnet mask for this. This is a class C subnetting, what we are doing. And in class C, always 8 bits is your host bits. Okay. Since we are not calculating the network bits over here, we are calculating the host bits. Okay. To submit. So out of 8 host bits, how many host bits you need for a particular requirement? That is why we are finding this pretty much. For 100 systems, we need 7. So we are taking only 7 host bits. So 7 host bits means what? 1 bit is going to the network. It means slash 25 is there. Because 24 is already network bits plus 1. 25. Understood?
Understood, sir.
Anyone else? Vandana?
Yes, sir.
Yes. Yes, Vandana, you understood.
Yes, sir.
Any question?
No, sir.
Are you sure you don't have any doubts?
No, sir. Actually, I'm doing this class again.
You are doing this session again. What happened?
Sir, because I missed some classes.
Yes, I guess you were there. I'm familiar with your name actually. You were there in my session, I guess.
Yes, sir. I was.
That is that.
So it's like I'm revising.
Okay, okay. Priyanshu is there. Priyanshu?
Yes, sir.
Yes, understood.
Yes, sir.
Anything if you have any queries, you can ask me, right? You know that, right? You have to ask me. Priyanshu?
No, sir. Everything is clear, sir.
Everything is clear. So, since everything is clear, all of you are not having any questions. I'm giving you the requirement right now. All you have to do is find out these addresses, the block size, the next subnet address, everything. Okay, all this is the intersection you have to find out. Okay, so this is the requirement, everyone, which basically goes like this. Sales department, you are having 8 systems. Finance department, you are having 50 systems. Technical department, you are having 30 systems. And marketing department, you have around 4 systems. Okay, let's say 3 systems. 3 systems. Okay, now this is what exactly you're having the requirement. Okay, and the network address what I'm giving to you to do submitting, that is 160.170.1.0/24. Okay, this is what exactly we're getting the network address. Okay, don't bother about the 160, 170 and all these things. This is an address. Just think of it like this. This is an address in which you have this part, we have network part, and this part is the host part. Okay. Or let me just write it like this. Just hold on. Otherwise you will confuse yourself. 200. Okay, like this. 200.170.1.0. This is your network address. It's a class C network. Okay. So do this. You are having around time is 15 minutes to complete this. Okay, everyone, you guys got the basic concept, right? The formulas, all these things are clear, right? Just utilize this, just refer this, over here. If you are getting stuck in something, okay, just refer this. How exactly I have done it, okay, just refer this. Okay, so exactly after 15 minutes, I will be communicating with you. Abhishek is there. Abhishek, yes, Abhishek.
Yes, sir. I want to take screenshot also. Please provide me because
Yes,
my
I'm
network
giving
is
you.
disconnected again and again.
Okay, this is the screenshot. Take it. Taken.
Yes, sir.
Okay, take this. Taken.
Yes, sir. Yes, sir.
Then take this.
Yes, sir.
And lastly, we are having this. This is the last section.
Yes, sir.
And similarly, this part. Taken this part.
Yes, sir. I
Okay.
taken.
Okay. That's it. Now do this requirement. Okay. Okay, everyone. So I'm muting my mic right now. All of you just to do this. And exactly in 12 minutes, I will communicate with you.